All right. Thank you all for being here and for your attention. My name is Joel. I'm here to present some joint work with Glen Weyl from Microsoft and my advisor, Chris, on some practical mechanism design that we did at a crowdfunding platform. So I'll start by asserting that public goods are good. Public goods, air quality, open source software, national parks, we all benefit from them, but they're hard to fund in traditional economic frameworks. Luckily, a mechanism called quadratic funding, or QF, solves the problem on paper. However, when it was implemented at a crowdfunding platform, it had a lot of issues in practice. So in this talk, I will describe our intervention, connection-oriented quadratic funding, or CoQF, which was quite successful. Folks voluntarily chose to use it in around 90% of the platform's activity, and it gave away $3.5 million. And hopefully, I'll give you some inclination for why I believe that CoQF and its theoretical foundations of pro-social utilities and plurality are also, potentially useful more broadly. Okay, so this is a mixed method study. We do this kind of standard economic stuff with proofs, simulations, finding equilibria. We also perform qualitative interviews with 8 administrative volunteers from the platform. So these are folks who aren't paid, but they are in admin roles, so they kind of have a good view of what's going on. We asked open-ended questions, and that's important because a statement like 2 out of 8 interviewees said X is not the same as 6 out of 8 saying the opposite. We were letting folks bring up whichever appraisals they thought were most appropriate rather than asking yes or no questions. Okay, so let me explain the context here. We've got public goods funding facilitated by a platform. The platform is called Gitcoin, and that name should immediately probably bring up 2 things for you. First off, there's Bitcoin in there. So this is a platform operating in the world of Web3 blockchain stuff. It's also got Git in there, as in the version control software. So this is a platform that facilitates a relationship between donors and open source software projects. Donors will use the platform to donate some amount of money each, and the projects directly get that money, just like on GoFundMe or any other crowdfunding platform. And from there, Gitcoin will also run this quadratic funding algorithm on the donation amounts to come up with an extra subsidy amount of money to award to the project. The other important detail here is that funding occurs in fixed rounds. So a round lasts for a set time period. It's got a fixed set of projects. And importantly, it's got a fixed subsidy pool, right? So they'll say, OK, there's 10 projects, donate to them for a week. Afterwards, we'll calculate these quadratic funding amounts and then normalize them so they match the size of the predetermined subsidy pool. OK, so the main evaluation that our interviewees had of quadratic funding was that it was a popularity contest. For them, popularity, and importantly, not quality, determined project success. So projects with big communities, lots of advertising, the ability to spin up Sybil agents, all tended to win out. You can think of Sybil agents as a type of synthetic popularity, if you will. And importantly, these things were de-linked from quality to them, right? So a big community did not necessarily mean that the project was deserving of funding from this platform. So 7 out of 8 folks were unhappy with these dynamics. 3 out of 8 called it a fairness issue. And I would argue that this does fit very cleanly into our kind of standard notion of an equal opportunity fairness issue, if you think of popularity as the sensitive attribute, right? That we don't want to be conditioning on, but somehow here we are. All right. So it turns out that pro-social utilities do a pretty good job at explaining these dynamics. So in earlier work, donors maximize the utility that they get from the project minus the cost that they paid. Very sensible, very reasonable stuff. You can also take a look at a sympathy coefficient model. This is actually very long-standing, going back to the 1800s, where donors maximize their utility for the project, sure, still minus the cost. But in the middle here, we've got this sum over all other agents of that other agent's utility times some variable alpha ij, which is meant to be a scalar kind of symbolizing the amount that I cares about J, or I's sympathy for J. So it turns out that if these pro-social utilities exist, then quadratic funding is always going to overshoot the optimal funding level. And that overshooting specifically, I think, is instructive because you can then extrapolate from there to show that if you've got a bounded subsidy pool, the projects with more homogeneous supporters will kind of take most of the money. So in other words, if I imagine 2 projects A and B, they could both bring the same utility to people, But if the donors to project A don't have any pro-social utilities towards each other, and the donors to project B do, then when these two projects compete for the same amount of money, quadratic funding is going to kind of incorrectly reward that second project with much more. Okay, so with that all said, I'll go on to describe the design for this algorithmic intervention. So it's inspired by plurality, which is a normative philosophy encouraging agreement across difference. And I hope the intuition makes sense here, right? So if we think that big groups of homogeneous supporters are distorting funding outcomes towards the projects that they donate to, then if we find a project liked by a bunch of distinct groups, a bunch of groups that don't have these pro-social utilities, well, maybe we should just even things out by giving those projects a boost. Now, in practice, working with these alpha values directly felt much too cumbersome in this case of this platform where information is limited and we have thousands or tens of thousands of donors. So we instead settled on a simpler abstraction to capture this social information, which is a set of social groups G. Each element of G is a subset of the total set of agents. These groups can overlap. And I'll give you a kind of bird's eye view of what CoQF is doing here. So really all we're doing is we're summing over all distinct pairs of social groups in G. And for each of those groups, we're going to look at the symmetric difference of those groups, people that are in just one group and not the other, and apply some function to their donation amounts. And that's kind of our way of trying to search for this agreement across difference. And I'll also note that you can write quadratic funding in a very similar way as a sum of different people in your set of agents of some function of those two people's donations. And so in fact, like one way to kind of look at this through the normative lens of plurality is to say that quadratic funding is already doing a plural thing with the individual as the unit of social difference, right? So if I really believe that each individual is their own kind of like isolated island of difference, then the way to encourage agreement across difference is to do exactly what's in the quadratic funding formula. But it turned out, or it seemed to be true empirically, that Gitcoin had a more networked world where a different version of difference felt more important. And lastly, I'll also mention that in practice, we calibrated G or kind of used donation information to come up with G. So donors to project X is one group, donors to project Y is another. And this was great because it let us preserve user privacy and not ask for any extra information when they were donating. Okay, so I'll talk about the results now. First one is that people use CoQF much more. So remember that funding here happens in rounds, and each round is administrated by its own set of people. So we let each round manager or set of round managers still use quadratic funding if they wanted, or use CoQF or blend the results together. And overall, 26 out of 38 rounds in the year and a half since we implemented this algorithm chose to use CoQF. A similar story is borne out when you look at the total amount of money distributed, with around 3.5 million going to CoQF, and around 500,000 each going to the two other mechanisms. All of our interviewees reported that CoQF was a better tool for distributing money. 5 out of 8 said it provided a clear signal of which projects would benefit their community as a whole. 3 out of 8 felt it was more fair, and 1 said that it did a good job of aligning round manager goals with grantee goals. So that's all good news. On the other hand, things weren't all rosy. So in particular, folks felt that CoQF did not do a good job at driving engagement. As one interviewee explains, one of the core points of Gitcoin is not optimal capital allocation. Not optimal capital allocation, right? It's the community building, the marketing, the collaborations that emerge. There are many collaborations that would not have happened without the rounds. So in other words, the purpose of quadratic funding wasn't just to give away money. It was actually also kind of had this second order effect of cohering this community together. And in fact, like precisely the thing that our interviewees felt was problematic about quadratic funding, the fact that it let these big groups and big communities have outsized influence on funding outcomes, was also what drew big communities to the platform, right? And so for this reason, 4 out of 8 interviewees worried that CoQF would have negative long-term effects on participation at the platform. Now, on one hand, this does feel a little bit more germane to Gitcoin's culture, right? So as mechanism designers, typically we want algorithms that are fair and efficient, right? These positive things that CoQF seemed to be checking the boxes on. It's not as common in our field to think about these second-order effects of drawing people in. On the other hand, I think it would be wrong to be dismissive of these complaints. Instead, I think it shows that, just like the Gitcoin culture relates to mechanisms in its own way, we as researchers have our own cultural proclivities, right? That forms the relationships that we have with algorithms. And instead of saying objectively that these desiderata are good or bad, I think it's important to remain relativistic and try to evaluate things in, situated in their own particular contexts. Okay, so I'll also discuss some simulations where we show that CoQF gives better welfare guarantees. The details of these simulations are in the paper, but I'll say that we spun up a few different scenarios. We found equilibrium donation amounts under QF, CoQF, and direct donations. And again, details in the paper. The important thing here is that the red line is CoQF, the blue line is QF, the gray line is direct donations, and on the y-axis here, we've got social welfare. I'm also realizing that I've really got to get the PDF of this chart for next time because this is very pixelated. But hopefully you can still see that the red line is higher, so we're doing better with welfare. These simulations, importantly, are not meant to convince you that CoQF is perfect, or they're not meant to kind of shut the door on a discussion of what CoQF is doing in terms of welfare, but hopefully they provide some kind of gut check or some kind of sanity check that something good is going on quantitatively with regards to the kind of normal economic tools that we use to think about these things. Okay, so when I look at all of this, I really see a story about how mechanisms encode human values and normative judgments. And in particular, if you were to ask me what the main kind of arrow in the Achilles heel of quadratic funding was, it's really that it inherited this idea from the rest of economics about like this very particular type of isolated selfish agent, right? Sometimes called homo economicus, right? I think that this turned out not to be true, right? Folks cared about the utility of other people. They cared about their relationships when they made funding decisions, or when they made donation decisions, rather. And I think that it's really worth asking, as we start to think about fair mechanism design in the context of community decision-making, whether or not some of these inherited assumptions still apply, right? So if you think about, participatory budgeting in a town, a very common, problem area in this neck of the woods, I think it's quite reasonable to assume that folks in the town will have different relationships based on the neighborhoods they live in, where their kids go to school, et cetera. And so to that extent, I really hope that some of the ideas either introduced or recapped in this paper, like pro-social utilities, plurality, and even the mechanism CoQF itself, can be a great jumping off point for exploring this other territory. And in particular, all is to say that, CoQF is really designed to be a very general framework that can hopefully be of interest outside of this funding platform. And there's also a voting version if giving away money isn't your bag. So thank you, and happy to take any questions.
Thank you. I think we have time for one question, if there's any. Okay, if not, I can jump in with one question. So I'm curious how you define the groups in CoQF. Is it completely data-driven, or do you have to predefine a set of demographic groups or something?
Yeah, so CoQF takes in a set of groups as input, and our thought there was that depending on which situation you're using it in, different sets of groups might make more or less sense. So, for decision making at a firm, you could use, the set of different departments as the set of G, and maybe a decision that folks from different departments all agree on is better than a decision that just one, set of folks feel really strongly about. At Gitcoin's case, because there was so little data, we ended up doing a kind of weird thing of using donation information to also create the set of groups, which did lead to a few weird things in practice, but it seemed to work okay. Yeah.
Thank you very much. Okay, let's give Joe another round of applause.